Hey everybody, welcome to part 2 of chapter 1, Introduction to Chemistry. I switched over to this side. Hopefully I won't interfere so much with the PowerPoint. Maybe next one I'll be in another spot. But anyway, we're going to talk about how to classify matter. And remember, when we talk about matter, matter is everything you can touch, see, or feel. And that's what we study when we're a chemist. All right, so we're going to classify matter. Okay, it can be subdivided into very specific categories. There's two overall. One is called a pure substance, okay? And you can tell it's a pure substance because it's always the same, all right? When you're talking about pure water, we talked about that before, it's always H2O, okay? If I get it anywhere, it's always H2O. Now, if I'm talking about tap water, that is not a pure substance because its composition changes. But a pure substance always has the same composition. So like in this case, they're showing you water, and then I think it's either salt or sugar. Okay. A pure substance has a definite fixed composition. Okay. Salt is sodium chloride, NaCl. It's always one sodium and one chlorine. If it's not, then it's not salt. Okay. So that's a compound. Elements on the periodic table, they are listed there. There's 118 elements, okay? And there's a periodic table in your book. A periodic table is like your best friend in chemistry. So make sure you always have one available because there's a lot of information on a periodic table. One of the things it tells you is what an element is. So elements would be like aluminum, carbon, nitrogen, oxygen. Those are all elements. They're always the same. Okay, here's an example of the other type of substance, which is called a mixture. Okay, here they got sugar. Sugar itself is a pure substance. Sugar that you put on your cereal or whatever is C12H22O11. It's called sucrose, and that's always its composition. So here's sugar. That's a pure substance. We're going to say this is pure water. So this is H2O. So these two are pure substances. When we mix them together, then we have a mixture. Okay. Why do I know it's a mixture? Well, I could have 1 spoonful of sugar in my water. I could have 3 spoonfuls. I could have a little pinch of sugar. You can vary its composition, so that's how I know it's a mixture. Okay. When you're talking about matter, again, when you're talking about, it can either be what they call homogeneous or you can call it homogeneous. I've heard it both ways. It's up to you to decide, but it means it's the same throughout. Okay. You can't see layers, you can't see different parts, you can't, that's homogeneous or homogeneous. Heterogeneous means you can see 2 or more distinct phases. And when you're talking about a pure substance, there is no heterogeneous. Okay? Elements are not heterogeneous, compounds are not heterogeneous. So mixtures would have homogeneous and heterogeneous. When you're talking about pure substances, they're always homogeneous, okay, or homogeneous, whichever way you want to say it. Okay? So if these definitely come into play with a mixture. If it's a homogeneous mixture, it means it's the same throughout. You can't see layers, you can't see different parts. If it's a heterogeneous mixture, you can see different phases. Okay? And when I talk about a phase, there's a boundary. Like if you have oil and water don't mix together. So you're going to have the oil on top. The oil is less dense, so it's going to be on top. That would be one phase on top of another. There's a boundary between them. Okay, here's another example. Ice floating in water is a 2-phase system. You've got a solid, the ice, and then you've got a liquid, the water that it's floating in. Okay, each of the systems themselves, the ice and the water, are homogeneous or homogeneous. They're well mixed, but when you put them together, now you can see the ice until it melts, of course, but you can see the ice as different. It's solid, different from a liquid. So when you mix them together, then you have a 2-phase system, and then you have a heterogeneous. Okay. So when you're classifying matter, most matter of the, there's 4 different types. 3 of them are homogeneous. Only 1 of them isn't. 1 of them's heterogeneous. Okay. So a mixture is 2 or more pure substances and it can be either well mixed or not so well mixed. Homogeneous or heterogeneous. Okay. But a mixture is a combination. You can always tell a mixture. Can you vary its composition? I mean, when I make salt water, I can put a pinch of salt, I can put a scoop of salt, I can put a cup of salt. Because I can vary its composition, I know it's a mixture. But if I'm talking about salt, Salt is always NaCl, one sodium, one chlorine. Cannot change that. So that's why I know it's not a mixture. Okay. Here again, sugar dissolved. This is a homogeneous mixture because it mixes up. If you put sugar in water, it'll dissolve, unless you put too much sugar. But it'll dissolve. But now you have sugar in your water. So you have two pure substances, but now they're mixed together. So now you have a mixture. And again, I can change the composition. It's like when people make Kool-Aid. Some people like it super sweet, so they add a lot of sugar. Some people just really don't like it that sweet, so they just add a little sugar. Okay, it's your personal taste. Okay, so you know those are mixtures because the amount of sugar is varied. Okay, a heterogeneous mixture has different composition, and again, it depends on where you take the sample, but you can see different parts. Other examples of heterogeneous mixtures, it would be like vegetable soup. When you get your first spoonful, maybe I got a couple noodles and a piece of tomato, and then the next one you got a bean and 2 carrots or whatever. You have different substances. They don't always look the same throughout. Okay, again, I talked about oil and water. That's a heterogeneous because the oil is less dense than the water. It won't mix. Okay, so you get a layer on top and then you get the water on the bottom. Okay, and that is a heterogeneous mixture. If you like Italian salad dressing, you shake it and you shake it and you shake it, but as it sits, it always separates. And again, that's a heterogeneous mixture because you can see different parts to it. You can see different layers. Okay, here's an example. What they did is they put different things together and then they put food coloring in them. Here's your oil on top. This might be some sort of alcohol. You know, they put different food colors in each and then they all form their different layers. Okay, a sample taken from the top of the mixture would have a different composition, because this would be your oil, than if you went down here. Okay, so if it's different in different places, it's heterogeneous mixture. If it's the same throughout, it's a homogeneous mixture, or another name for it would be a solution. Okay, a solution is a well-mixed mixture. Okay, so when you're talking about separating mixtures, that's another way you can tell if it's a mixture, if you can easily separate it. You're going to use parts of its identity to separate it, and once you separate them, they're still the same thing. Like again, if I have salt water, I can boil off the water and then I get my salt back. It's still salt. Okay, here I have boiling, filtration, flotation, magnetism. Okay, if you put iron filings and mix it in with sand, you can take an iron and pass it over the sand and pull out the iron. So you're using the fact that it's magnetic to separate it. And again, that would tell you it's a mixture. Okay, oh, I guess that's what it, oh, here it's sulfur, sorry. Here's sulfur. Sulfur is an element, pure substance, okay? It is not magnetic. You put a magnet down there, nothing happening. Actually, it looks a little like scrambled eggs, doesn't it? Over here we got iron. Iron is a pure substance. It's an element, okay? I'm separating it. I mean, it's attracted to the magnet. So now if I make a mixture of these two guys, I mix them up, I can still use the fact that iron is magnetic to separate that mixture. So that's why I know it's a mixture. Another way I know it's a mixture, if you look, I can mix these in any proportion that I want. They don't have to be 1:1. They don't have to be 2:1. Like water is 2:1, 2 hydrogen to 1 oxygen. In this case, when it's a mixture, you can put it in any amounts that you want. Okay, so here is a little chart to help you. If you look, here's everything. All matter, everything you can touch, see, or feel. Okay, we got pure substances or we got mixtures. These are, everything can be one or the other. Okay, so if it's a pure substance, it's always going to be homogeneous. It's always going to be the same throughout. If it's over here in a mixture, it can be a pure substance. I mean, it can be well mixed or not so well mixed. So it can be homogeneous or heterogeneous. But if you're on this side, it's always homogeneous. And there's two pure substances. There's elements and there's compounds. Elements are on the periodic table. If you combine elements, you know, to make a new substance, that would be a compound. You can break a compound down, but you can't break down an element. Over here we have mixtures. Okay, so we look at our substance, we can't figure out what it is, but we know there's 2 or more substances in there. We know it's a mixture. If it is well mixed, if it's, you know, you can't see layers, you can't see different parts, that's called a solution. And a solution is another fancy name for a homogeneous mixture. It's in one phase, everything's mixed up well. Heterogeneous, 2 or more phases, you can see different things in them. Okay, so all matter is either a pure substance or a mixture. All pure substances, there's 2 groups, elements and compounds. If it's a mixture, you have solutions or heterogeneous mixture. Well mixed, not so well mixed. These guys are all homogeneous, but if you take 2 or more elements and combine them chemically, you can get a compound. So you can break a compound down into element, but you can't break an element down anymore. That's it. So our question is, which of the following is a heterogeneous mixture? So I'm looking for something, first of all, that's a mixture. It's not always the same composition. And I'm looking for something that's not so well mixed together. Well, baking soda is actually a compound. Gasoline is a solution. It's a well-mixed mixture. I hope you don't see chunks when you put gas in your car, because I wouldn't put that in my car. Grape juice is usually, and grape doesn't have any pulp, so you don't have to worry about it. That'd be a well-mixed mixture. That'd be a solution. Copper metal, that's an element. So it's got to be soil. Okay, if you look at soil, you put a handful of, look at a handful of soil, you can see rocks in there, you might see bugs in there, you might see dark parts, you might see some sand, there's all kinds of different things in soil. So we know that that's the heterogeneous mixture. Okay, which of the following is a homogeneous mixture? Okay, now remember, homogeneous, it can be a solution, it can be a pure substance, or it can be, which is an element or a compound. So you've got those options. Heterogeneous is just a mixture. Well, if we're looking at these, I've got, which of the following is a homogeneous mixture? Okay, so it's got to be a mixture. Carbon dioxide isn't going to work because that's a compound. Mercury is an element. So these are pure substances. They don't work. So I got maple syrup, concrete, or Italian salad dressing. Now they got to look the same throughout if they're homogeneous. Again, another name for that is a solution. Well, concrete, I don't know about you guys, but when you look at concrete, you see little rocks in there. Unfortunately, mine's cracks in there with weeds in there. Italian salad dressing we already talked about. When you shake it and you shake it, and it might look like it's mixed up, but when it sits there, then it starts to separate. So it's got to be maple syrup. And again, hopefully not old maple syrup, because old maple syrup, you start to get the sugar precipitating out. But that would be an example. Okay? All right. Filtration is a common method to separate components of what type of mixture. If you're filtering something, you probably want to have, you can't do 2 liquids. You can't do gases. So I'm thinking we need where something, because filtration is, we have the filter paper and you pour it through and it catches something. So it's going to catch a solid. And what do we got here? Heterogeneous mixture of a solid and a liquid. Homogeneous mixture of a solid and a liquid. Well, if it's homogeneous, solid and a liquid, that means it dissolved, and that wouldn't catch in the filter paper either. So it'd have to be this one. These guys wouldn't work because 2 liquids isn't going to help. You got to do something else for them. So it would have to be a heterogeneous mixture where you can see different parts, and then the solid is in the liquid, but the solid doesn't dissolve. Because in this one, if it dissolves, then you can't see it, and how is the filter paper going to do any good anyway? Okay, and that's that. So we're done with chapter 1. There's a quiz for you to do right after you watch this. And then again, I'm going to put in some links and stuff if you want to look for other things that you can do to help you with this chapter. You don't have to go through them. It's your choice. But there is a 10-question quiz on classifying matter. And the instructions are in that as well. So, and again, if you have any questions, please let me know. And that's it. Signing off.